Welcome back, everyone, to the eCoreAcademy e-learning platform today. My name is AJay, back with yet another Algebra 1 video for you all. And today we're going to be looking at the linear equations format of our Algebra 1 course in our third unit. And we're going to be focusing on writing in point slope form. This is going to be a predecessing video to more advanced topics. So we're going to look in correlating all three of our equations, our standard linear equations. So far in our course, we've done our slope-intercept form, but now we're going to be moving on to our point-slope form. In our next video, will be on our very own standard form lesson. I believe that standard form is probably the most difficult. So in that way, we're going in least difficult to probably most difficult in this manner. So this video was actually made by Tania Patel, the other teacher here at Algebra 1, and she helped in making this video, as I will be partnering with her in helping presenting this video and also adding some of my speaker's notes to you and some of my advice and guidance when it comes to solving the problem format. So we're going to look at our point slope form, identify what it is, when to use it, and also some practice problems you'll have in correlating with either the slope-intercept form or just plain point slope form and seeing why it is used. So before we jump into today's lesson, please make sure to subscribe, hit that like button, comment down below, and also feel free to share this video. Feel free to turn on post notifications as well. All right, let's jump right into it. So this is what the raw point slope form really looks like. I'm going to go through what the notation is, and then I'll explain what it is in correlation to something that you do know, your basic slope formula, and then of course your point slope form that we already learned. So the point slope form goes as is. It's y2 minus y1 equals m times x2 minus x1. So all of these values are very representative, and these values you probably are already familiar with. So let me underline m. M you might already be familiar with. It's merely just slope. It stays consistent with all linear equations. It's your slope. And then of course you're given two different subsections here, y2 minus y1 and x2 minus x1. If you think of your slope formula, when you calculate slope, it's merely y2 minus y1 over x2 minus x1. So that's literally what we're replicating right here. We're literally taking this and piecing this apart, this formula apart for your slope, and we're merely reconstructing it in a point slope formula in an equational format, giving it relativity. So we're going to put this on this side right here. So when we're doing this, it's actually very interrelated. So when it comes to your y2 minus y1, that's merely delta y, your difference in your y values when you're given two ordered pairs on a line. And then of course x2 minus x1, it's your difference in your x coordinates. So once you have the differences of both, merely you divide the x coordinate difference into the y coordinate difference and you get your slope. However, this is merely a reconstruction of it. The point slope formula is literally created by taking the slope formula and then you're just cross multiplying it. So what you're doing is you're reversing the process by saying the difference of y equals the slope times the difference of x. Rather than dividing y, the difference of y, by x to get m, you're merely reversing it by multiplying m with the difference of x to get to y, since you're dividing x into y. So that's merely a reconstruction of this formula, of the original formula, into an equation, and it still maintains the same relationship, and you can use it for even more things on an equational format. And all these equations you can always translate into standard form, into slope-intercept form. They're always interchangeable once you're given the right variables. All right, so now let's take a look at how exactly we're going to use it. What are the purposes and what's the process? So the first thing that we're going to do is we're going to replace the x1 and y1 in the equation itself. Remember, x1 is one of the coordinates for x, and y1 is merely y subscript 1. It's one of the y coordinates. And of course, x1 and y1 are the same ordered pair. So in that same ordered pair that you're given, you'd substitute it for x1 and y1. Then, of course, you'd also be given the slope most of the time when calculating for point slope form and translating it maybe between slope-intercept form and standard form. You're most of the time given m, your slope, so you plug that in. If not, you must find the slope. So if you don't have the value for m already given to you, then you're most likely going to be given two different ordered pairs. And with those two ordered pairs, you calculate the slope, plug it in, and find your equation. And then finally, when it comes to answer format, in these practice problems following today, we're going to be specifying what exact forms we want you to put the answer in. However, you can always choose what forms to put them in when an answer or a question doesn't specify. I like to leave things in slope-intercept form oftentimes, but if it prompts you to use point slope form, always use it. And of course, lastly, just before we move on, you might be thinking, why do I use the point slope form? Why can't I just use the slope intercept form? Well, the point slope form does literally have an advantage, and it can actually be translated back into the slope intercept form. But the reason we use point slope form is to calculate more points on a graph. So when it comes to slope intercept form, you're able to calculate the properties of line much better, representing it. But if you want to calculate whether or not a lot of points on a line are actually within, on an actual line, and you want to calculate the slope of the lines, or you want to calculate the slope of a line with ordered pairs, it's much easier to do so with the point slope form, actually calculating the slope when given 2 points. It's a lot easier, or a single point, and you're given an entire line on a graph. It's easier to calculate the slope with this graph. Plugging points in and getting your slope is a lot easier. All right, so now let's move on to practice problems. So this very first problem, we're going to be finding the equation of a line in point slope form if the line goes through 5, -6, our ordered pair, and it also has a slope of 6. So we're given the slope n. So some things I'm going to highlight. The answer format is going to be in point slope form, very important. And then of course it's going to go through our original ordered pair of 5, -6. This 5 right here is going to be our x1, our original x coordinate, our first x coordinate, and then -6 is going to be our y1, obviously correlating with x1. And then finally, we're going to be given a slope of 6, so that means that m equals 6. M is always slope in linear equations. So now what we're going to do is we're going to create our original equation for our point slope form, put that in, and then we'll start to plug in our variables to create the equation. So the original equation is y2 minus y1 equals m times x2 minus x1. So once we're given this original equation, we're merely going to substitute our values in for our y's, our x's, and our m's. So we know what y1 is and we know what x1 is. So let's plug those in first. So we get that y2 minus 6, y2 minus -6 equals our m, of course, we can also plug that in. That's going to be 6 times our x2 minus 5. When we simplify, we're given that y plus 6 equals 6 times x minus 5. Now the reason why I substituted y for y2 is that since y2 is the only y left in this entire equation, we can merely leave it as y. We don't need to substitute it as y1. The reason why it's written as y subscript 2 minus y subscript 1 is because there are 2 different y values for 2 different ordered pairs, but in this case, we don't have multiple y's or x's, so we can leave them as y and x. So that's actually going to be our equation. We're not going to further simplify by multiplying 6 out, because then we're going to be going to our slope-intercept form. This format of it helps us calculate better with coordinate pairs, and it helps us calculate the slope easier as well when given, if we weren't given the slope. But we've written it in point slope form now. Let's take a look at another problem with point slope form. We're going to use the same process, practice with some coordinate pairs, and plug in our slope. So of course, it's point slope form here as indicated. So we're going to write out our equation. So y2 minus y1 equals m times x2 minus x1. And then of course, we're given our ordered pair here. This guy -2 here is going to be our x1. And then of course, 5 is going to be our y1. And then finally, we're given our slope of -3/4. That means that m is going to equal -3/4. So once we're given that, we can start plugging that in, of course. So y2 minus our y1 of 5 equals -3/4 times our x2 minus -2. And then of course we can simplify this further on the right hand side, so we get that y minus 5 equals -3/4 times x plus 2. So that's our point slope form final answer right there. All right, so now let's move on to our last problem in this first section of problems here. And we're going to find this equation. We're going to practice some more with their slope-intercept form, just so that you can see some similarities. So this is merely another problem here with linear equations, the whole overall theme. We're going to practice with calculating, just to remember, refresh you guys with using your slope-intercept form. So in this problem, we're going to write our final equation, our final answer in slope-intercept form. So we're going to start there. And then, of course, the line is going to intersect our 2 points, -8, 5, And of course, our line is going to intersect our two ordered pairs, which is going to be negative comma 5, and of course 6 comma negative 2. So now that we have negative 8 comma 5 and 6 comma negative 2, here we're merely going to plug those back into our equation. We're going to find that slope initially, plug those coordinate pairs back into the equation, and find what the y-intercept is. So first, let's start off by calculating the slope. So n equals the change in y, so it's y1 minus y2, over x1 minus x2. It doesn't matter which ones we assign, as long as y1 and x1, they correlate with the same coordinate pair. So we're going to plug in this case, negative 8 for y1, 5 for x1, sorry, reverse, 5 for y1, negative 8 for x1, and then we'll do that same thing with x2 and our y2. So we'll plug in our negative 8 here at the bottom, negative 8. That's going to be subtracted by our x2, which is 6, so it's going to be minus 6. Up top, we have y1 minus y2, so that's going to be 5 minus negative 2. When we calculate that, 5 minus negative 2 is 7 up here. And then negative 8 minus 6 is going to be negative 14. Therefore, our slope is going to be negative 1/2. All right, so now that we've calculated our slope, let's take our slope-intercept form equation, and that is y equals mx plus b. Now we can substitute m for our slope that we calculated, so y equals negative 1/2 x plus b. And the only thing we're missing now is our slope-intercept. So let's plug in some coordinate pairs. So let's start off with our first ordered pair. We'll just plug that in now. So we'll plug in negative 8 for y, sorry, 5 for y here. That equals negative 1/2 multiplied by our x, which is negative 8, plus b. 5 equals negative 1/2 times negative 8 is going to be 4, plus b, and we get that b is going to equal 1. So the original equation now, we can plug in 1 for b. We get that the original equation is going to be negative 1/2 x plus 1. All right, just a quick refresher, very quick. It's nice to go back through these problems. And of course, I'm going a little bit slower so that I can talk to you guys and annotate at the same time, trying to explain it. But of course, you guys are probably zipping past this at this time. But it's always good to look at everything that we do know when it comes to understanding things that we don't know, the newer topics. All right, so the second half of these practice problems, what we're going to do is we're going to find the slope-intercept forms of the first two examples. And we're actually going to be given them in point-slope form. So we're going to translate from point-slope form into slope-intercept form. We're given the equation of y plus 6 equals 6 times x minus 5, and we're going to translate this into slope-intercept form. All right, so let's start off by rewriting the equation right big and bold here. I always like to rewrite it so that I actually start to memorize what the numbers are. So 6 times x minus 5. And then the next thing that we're going to actually do here is we're going to expand out 6 times x minus 5. I'm going to distribute that 6 across to the x and the negative 5 just to get rid of the parentheses. So what we're going to do here is we're going to leave y plus 6 on this side. We're going to multiply 6 to x and 6 to negative 5 with the distributive property of multiplication. So 6 times x is 6x, 6 times negative 5 is negative 30. And now all we have to do is isolate y on the left-hand side of the equation. So in order to do so, we have to subtract 6. So when you subtract 6, you get y equals 6x minus 36 in this case. And that's going to be your final your final answer in point-slope form, because of course we have our y variable isolated on the left-hand side. That's equal to your 6, which is essentially your slope, mx, so 6x. And then minus your y-intercept, which is negative 36. All right, and let's take one more example here. We'll translate this final point-slope form equation into slope-intercept form. All right, taking the same process and the same steps, we'll rewrite this nice and bold. Y minus 5 equals negative 3/4 times x plus 2. Then, of course, we'll distribute the negative 3/4 across to x and 2 separately. That means that y minus 5 is equivalent to negative 3/4 x minus 6/4. All right, so now that we have this on this side, the x, so negative 3/4 x minus 6/4. Now what we're going to do is merely isolate y on the left-hand side of the equation. So we're going to add 5 to both sides, so we get that y equals negative 3/4. x, and then when we add 5 to both sides of the equations, we get 5 and 6/4, which is also 6 and 2/4, or 6 and 1/2. So plus 6 and 1/2. All right, so that's going to be our very final answer. I promise, that's it. That's our final answer right there. As you can see here, it's very important to take our initial knowledge of the slope-intercept form, attach it to some things that we don't know, like the point-slope form, and it helps you better understand. So we'll take that very same approach when coming to our standard form equation, which I know is probably the most difficult linear equation to understand, in our next video. Alright everyone, so I hope you guys enjoyed this video. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe and hit the post notification bell. Check out our website at www.ecoreacademy.org. We have note sheets, quizzes, worksheets, everything there to help you with our videos. It's all free, so all you have to do is sign up. We also have our Gmail, eCoreAcademy@gmail.com. You can email us there if you have any questions. And also check out our socials in the description box below: Facebook, Twitter, Instagram, Pinterest, and of course, TikTok. Our newest TikTok account is up and running. Alright everyone, so that'll be it for today's video. I hope you guys enjoyed. This has been AJay Raj, and I'll see you guys in the next one. Peace.